Welcome to G Fun Facts Online. High in the celestial sphere, within the iconic constellation of Orion the Hunter, a fiery orange-red star marks his right shoulder. This is Betelgeuse, a star that has fascinated humanity for thousands of years. But recently, this ancient beacon has taken center stage in a cosmic drama filled with puzzling behavior, hidden secrets, and the ever-looming promise of a spectacular death. In late 2019, astronomers, both professional and amateur, noticed something deeply unusual. Betelgeuse, consistently one of the 10 brightest stars in our night sky, began to fade. And it wasn't a subtle change. Over the course of a few months, it lost more than 2/3 of its normal brightness, plummeting from a top-tier star to barely cracking the top 20. This event was so dramatic, it was quickly named the Great Dimming. The astronomical community was buzzing with speculation. The most thrilling possibility was that we were witnessing the final death throes of a star. Was Betelgeuse about to go supernova? A supernova is the most powerful explosion humans have ever witnessed, the cataclysmic end of a massive star's life. If Betelgeuse were to explode, it would be an event unlike any other in modern history. The explosion would be so brilliant it would be visible from Earth during the daytime and would outshine the full moon at night for weeks. The Great Dimming looked like a potential preview of this grand finale. However, as telescopes like the venerable Hubble Space Telescope turned their gaze toward the fading giant, a different, though no less fascinating story began to emerge. The culprit wasn't an impending core collapse. Betelgeuse wasn't dying, at least not yet. Instead, it had, for lack of a better term, sneezed. The evidence pointed to a colossal surface mass ejection. Imagine a solar flare from our own sun, but scaled up to an almost unimaginable degree. Betelgeuse had violently ejected a massive plume of its own superhot plasma out into space. This blob of stellar material, weighing several times as much as our moon, traveled millions upon millions of miles away from the star. As this ejected material moved further from the intense heat of Betelgeuse's surface, it began to cool and condense, forming a vast, opaque cloud of dust. This cosmic smokescreen drifted between us and the star, partially blocking its light from our vantage point on Earth. So the star itself hadn't actually dimmed. It was simply being obscured by a giant dust cloud of its own making. It was a cosmic illusion. Hubble's observations were key. In the months leading up to the most significant dimming, it saw evidence of this dense, heated material moving outwards through the star's extended atmosphere. By August of 2020, as Betelgeuse began to return to its normal brightness, subsequent studies confirmed the presence of this dust, solidifying the theory. The star had burped, and the resulting cloud was enough to fool the entire planet into thinking it was about to blow. Just as the cosmic dust settled on the mystery of the Great Dimming, another, much older puzzle surrounding Betelgeuse was about to be solved. For centuries, astronomers had suspected that Betelgeuse might not be a solo act. There were subtle hints in its behavior that suggested the gravitational pull of a hidden partner. Specifically, Betelgeuse has two main cycles of brightness variation. The primary one is a pulsation that occurs roughly every 400 days, a common feature for a star of its type. But there was also a longer, secondary cycle lasting about 6 years that nobody could quite explain. A companion star was the leading hypothesis, but finding it was a monumental challenge. Searching for a relatively small star next to the overwhelming glare of a red supergiant is like trying to spot a firefly next to a stadium searchlight from miles away. The turbulent nature of Earth's own atmosphere further complicates things, smearing out the light and hiding any faint objects nearby. But in 2025, a team of astrophysicists achieved a remarkable breakthrough. Using the advanced allopaque speckle imager on the Gemini North Telescope in Hawaii, they finally did it. This instrument is designed to overcome atmospheric distortion by taking thousands of very short exposures, effectively freezing the atmospheric twinkling. By combining these thousands of snapshots, they can reconstruct an image with incredible sharpness, sharp enough to cut through the glare of Betelgeuse. And there it was, a faint point of light, the elusive companion star. They had directly imaged Betelgeuse's hidden partner, solving a millennia-old mystery. This newfound companion is a hot, blue-white star, estimated to be about 1.5 times the mass of our Sun. And its location is truly bizarre. It orbits Betelgeuse in an incredibly tight embrace, at a distance of about 4 astronomical units. That's just 4 times the distance between the Earth and the Sun. To put that in perspective, Betelgeuse itself is so enormous that if you placed it at the center of our solar system, its surface would extend out past the orbit of Mars, and maybe even to Jupiter. This means its small companion star is actually orbiting inside the extended outer atmosphere of the red supergiant. This is the first time such a stellar pairing has ever been directly observed. This discovery provides a compelling explanation for that mysterious 6-year brightness cycle. As the smaller companion plows its way through the tenuous outer layers of Betelgeuse's atmosphere, its gravity creates a wake, a disturbance that affects the supergiant's brightness in a regular, cyclical pattern. The two stars present a fascinating and stark contrast. Betelgeuse is an ancient, dying giant in the final phase of its life. Its companion, however, is a young star that has yet to even begin the main phase of its life cycle, the fusion of hydrogen in its core. It's a cosmic case of cradle robbing. But this strange partnership has a grim future. The companion star is doomed. In a few thousand years, as Betelgeuse continues to expand in its death throes, it will inevitably consume and cannibalize its smaller partner. While the Great Dimming and the discovery of a companion have solved major puzzles, they all lead back to the ultimate question: when will Betelgeuse finally explode? Red supergiants like Betelgeuse are living on borrowed time. They are stars that have exhausted the primary hydrogen fuel in their cores. Having fused hydrogen into helium, they've moved on to fusing helium into heavier elements like carbon and oxygen. This process releases tremendous energy, causing the star's outer layers to swell to immense proportions. Betelgeuse's radius is about 700 times that of our Sun. This red supergiant phase is the final, brief act before the grand finale. Eventually, the star's core will be composed of iron. Iron fusion does not release energy, it consumes it. At that point, the outward pressure from fusion that has supported the star for millions of years will cease. Gravity will win. The core will collapse in on itself in a fraction of a second, rebounding outwards in a cataclysmic explosion known as a Type II supernova. Until recently, the consensus was that this event was likely thousands, or even tens of thousands of years away. But new data has thrown a wrench in that comfortable timeline. Observations from the James Webb Space Telescope have given us an unprecedented new look at Betelgeuse. Because JWST sees the universe in infrared light, it can peer through dust clouds and analyze the heat and motion on the star's surface in incredible detail. And what it has seen is a star in a state of chaos. The JWST has revealed that Betelgeuse's surface is not gently simmering, it's in a state of violent, convulsive turmoil. The telescope has detected gigantic oscillating plumes of heated gas, some as large as our entire solar system, expanding and collapsing. It has seen powerful shock waves rippling across the stellar surface, driven by the turbulent convective motions deep within the star. This isn't the picture of a star in a stable pre-supernova phase. This is evidence of extreme instability. These violent conditions could potentially destabilize the star's core far more quickly than our previous models suggested. The chaotic sloshing and magnetic interplay could accelerate the process, leading to core collapse. While scientists are quick to point out that we still cannot put a precise date on the explosion, the JWST findings have raised the unsettling possibility that the cataclysm might be far closer than we thought. It could be centuries away, or it could be much, much sooner. The clock is ticking, and it might be ticking faster than we assumed. When the moment finally arrives, It will be the greatest show in the night sky for generations. At a distance of roughly 700 light-years, the supernova poses no danger to Earth. We are well outside the kill zone for any harmful radiation. But we will have a front-row seat to an unparalleled astronomical event. The light from the explosion will reach us and dazzle us. For weeks, maybe even months, the supernova will be so bright that it will be easily visible in the daytime sky. At night, it will shine brighter than the full moon, casting faint shadows on the ground. It will provide a once-in-a-civilization opportunity for scientists to study the death of a star in real time and in exquisite detail, testing our models of stellar evolution and the creation of heavy elements. The story of Betelgeuse is a perfect example of science in action. It's a dynamic, unfolding mystery where each new observation peels back another layer, often revealing more questions than answers. From a puzzling dimming event that turned out to be a cosmic sneeze, to the discovery of a long-lost companion star, to the ongoing surveillance of its violent death throes, this red supergiant continues to be a source of scientific intrigue and public wonder. It is a living laboratory, allowing us to probe the secrets of how the most massive stars live and die, forging the very elements that make up our world. So the next time you look up at the night sky and see the constellation of Orion, pay special attention to that bright reddish star on his shoulder. You're not just looking at a distant point of light, you are witnessing a grand cosmic drama, a story of life, death, and spectacular rebirth, written in the fiery heart of a giant. Thank you for listening to G Fun Facts Online.